What is linear regression? What are we going to do with linear regression? What is linear regression? All of you, please type it in the chat window. If you are not sure, you can use Google also. So it is an algorithm, right? Linear regression is an algorithm using which we can solve the regression problem. Number is solve the regression problem. Another thing is you can model the relationship between independent variable and dependent variable. So model the relationship between independent variable and dependent variable. We can model the relationship using linear regression model. Okay. It helps us, in simple term, it helps us find out how one thing affects other thing. How one thing affects other thing. Okay. Supposing you want to know how the hours of study affects your test score. The more the hour, the general phenomenon, the more the hour you spend preparing for your test, obviously your score will be more. Am I correct? So with the help of the linear regression algorithm, or it helps us to find a mathematical equation that best describes the relationship between the hours spent in preparing for the exam and then the test scores. If I spend 8 hours, how much what is the estimated test score, right? And if I spend 16 hours, what is the estimated test score, right? So that is what we can find out the relationship between these two using linear regression model. What is the equation for the linear regression algorithm? What is the equation for the linear regression algorithm? Linear regression equation. Y is equivalent to mx plus c. Okay, here the c is the intercept. Yes, you are correct, Sri and Deepika, you are correct. And here the m is the slope. What is slope? What is intercept? We discussed it. What is slope? What is intercept? And here the y, what does it tells us? So this is your, for example, test score. How much I can score? What is the estimated score? Or in other words, right, estimated housing price. Sorry, the other example is estimated housing price. I want to estimate the housing price. How much am I going to get? If I invest money in buying the house in a specific locality with so-and-so year old house, how much money can I expect it, right? So why is that dependent variable? Yes, you are correct. That's correct. Y is also called as a, so these are all estimated housing price. Okay, this is also called as a dependent variable or response variable or target variable or output variable. Output. All these terms refer to the y variable. All these things are so dependent variable, response variable, target variable, output variable. Okay, this is what. And what is x? X is your independent variable. It is also called as an independent variable. And predictor variable. They use different terms. All of them are same, but they interchangeably use any one of them. Independent variable or input variable. Independent variable, predictor variable, input variable. Okay, so these are so the single thing, right, is represented in a different way. Okay. And the dependent variable, why is your dependent variable responsible or target variable output variables, right? So with the help of the X, the independent variable, we can make a prediction about our dependent variable. So why it is dependent, why it is called as a dependent variable? Because the dependent variable is, as the name says, it needs an independent, it needs a variable, right? It depends on other variables. The dependent variable, as the name suggests, it depends on other variables. It's something like, mother, right? In your house, housewife, she's a housewife mother. Mother is a dependent. She is depending on her husband, right? She is a dependent. She is depending on her husband and son. Husband is very sick, he's old, and his mother is, and he is earning very less salary. And son is earning good, right? Moderately earning. So in that case, mother is depending on two different people, father and son. If both of them are not alive due to some accident, let's assume that, okay, what will happen? She cannot survive, right? Similarly, in the case of dependent variable, you need to have an independent variable in order to make at least you need to have one independent variable to make a prediction. Okay, the dependent variable is depending on other variable, that is called your independent variable. So what is the slope? What is slope? Here, let's take, for example, test score. What does that tells us, the test score? So, okay, why don't you give me an example for test score with the slope? Krishna, why don't you tell now? What is the use of slope here? How much our test score changes when you study for an extra hour? A 1 unit increase in an hour, or an hour increase in, right? A 1 unit increase in hour, how much the test score can increase? That is what it tells us. That's why I have given you the best example, the auto fare. For example, in the case of auto fare, I want to predict the auto fare, and here instead of saying mx plus, this is a traditional way of saying that. Here I'm going to, instead of c, I'm going to say beta naught. That is what your intercept. Beta 1 is your slope, and here miles. Okay, into miles. Beta 1 into miles. So here, for example, a person travels 10 miles, and here the beta 1, let's know the beta 1 and beta, these two parameters are estimated by the model itself, the algorithm itself, in the case of statistical software, and 2 into 10. Okay, this is 2 is given by my model. Okay, you don't have to compute it. You assume that way. Okay, and plus this one is, let's 5. Beta naught is 5. So 25 in total. If you add all the things, take a product and add this, is going to be auto fare. Estimated average auto fare is, you need to always say estimated average auto fare. So why do we say estimation? Why do we say estimation? What do you mean by estimation? Yes, you are correct. Yes, Sri, you are correct, right? Sri and Shaundarya, you are correct. Estimation is not the definitive number. It can vary. It can vary. So how many of you remember confidential interval? Here also it is applicable. Instead of saying I can come to office tomorrow by 10 a.m., we used to say anywhere between 9:30 to 10:30 I'll be there at office. We tell them, right? So that will be safe. It is estimated. You estimate, because tomorrow you do not know what is going to happen. In case of any riot happens, or in case of any a political party rally happens, right? So in that kind of situation, due to heavy traffic, you may not reach on time. So usually what we do is we use similarly, right? The estimation is something. For example, if somebody comes to your home and, sir, you call a painter to paint your house. Let's assume that your house is a very big house. And you can ask him, give me an estimation to paint the whole house, right? They'll say, sir, plus or minus. So they'll give some money. They'll quote some money. It'll cost you 7 lakhs or 8 lakhs because you have 4 floors and it's an apartment. You need to shell out at least 8 lakhs, and then you will ask them, okay, is this 8 lakhs only, or will it cost more? What you will tell? So in the quotation, if you see, they specify the cost is maybe 8 lakhs, plus or minus 20% variation will be there. Because we did not measure your entire apartment, measuring your apartment will take time. And also during the painting time, only we will get to know where and all problem is there in the walls, because it's a big apartment. So estimation, there is a degree of unpredictability will be there. How much percentage degree of unpredictability? Probably 10 or 15 percentage. Okay, that is what the degree of unpredictability. Okay, estimation. So autofair in this case, the slope, what it tells us is when a 1 unit increase in the miles, for example, if it is going to be 11, so 22, right? 2 times your autofair will get increased. So right, your autofair will increase twice the time, twice the time. Your autofair will, for a single unit increase in your miles, for 11 kilometers. For example, if I say 20 kilometers, so 20 into double the time, right? Double the time, your autofare will increase. This is how you need to tell. The slope is, 1 second. So, okay. So how do you tell this one at the time of interview? So what is slope? If somebody is asking you, so so you can give this example, right? If the estimated value of beta 1, in this case slope is 2, it means that for every additional kilometer travel, the autofare is expected to increase by 2 units on an average. 2 units increase on an average. I'll just write it here. Don't forget it, okay? See here, I'll just put star here, or I'll just go to the next page. Let me do. So we discussed about the autofare. I'll just put it here. Autofare is equivalent to the beta naught plus beta 1 into uh, the miles travel or kilometer travel. Okay. Here, this is your response variable or dependent variable. This is what your x, which is your independent variable. So we are talking about the simple linear regression model. Simple linear regression model will consist of only one independent variable. Okay, this is your independent variable. Only one independent variable. Okay, in this case, let's say the beta 1 is 2 and the beta naught is something. So we are talking about the slope. The beta one is slope. Here, how do we define this one slope? How do you explain it to the management or in the interview? What if they ask you what is slope? What is the rate of change in y when x changes? What is the rate of change in y? Slope is equivalent to the rate of change in y when x changes. That is what your slope. What is intercept? How many of you remember? Guys, please remember it. It is not a school time, college time. Here, simply they will fire you. They send you out. Okay. You might be thinking, okay, sorry. Intercept is, what is that? Intercept. The line which cuts the y-axis is your intercept. But if you have to tell the story, so when the x is 0, the estimated value of y, the estimated average value of your y. Okay, that is what your intercept. Intercept is not always meaningful. There are cases it is meaningful, it is really helpful, especially when you use the one hot encoding. And yeah, so that kind of situation, the intercept is very much helpful in terms of estimating your, estimating your target outcome variable. It is really helpful that time. Okay. The slope is nothing but the rate of change in y. So in this example, a 1 unit increase in a 1 unit increase in miles. Right. So what will happen? The 1 unit increase in miles or miles travel, right? Miles travel, the expected or estimated, the expected, the auto fare, right? The auto fare is expected to increase by 2 times. On an average, right? On an average. The 1 unit increase in miles travel, the auto fare is expected to increase by 2 times on an average. Okay. Fine. So now you understood what is slope and what is intercept. And what is the next thing? The next thing is, yeah, so this is what the slope and intercept. Next one is, we will see what is positive correlation, negative correlation. See, in the case of linear, sorry, there was a network issue. My system got, not my system, my Zoom got rebooted because of restarted, okay? Because of the net problem, net connection. But anyhow, somehow, thank God. So I just got connected again. So here in this case, 1 second. Yeah, linear regression, right, is a method in mathematics or statistics. It helps us to understand and predict the relationship between two variables, right? Predict the relationship between, we can say that also, predict the relationship between, what is the relationship exists between these two variables, the x and y. For example, if you visually look at this, here the y-axis is your auto fare, your x-axis is your miles. So here, 10 miles, 20 miles, 30 miles, 40 miles. As the miles traveled increases, the auto fare also increases. With the help of the linear regression model, we can find out how one thing affects the other thing. In the sense, how the how the auto fare or how the increase in miles affects the auto fare. Okay, how the miles increase, how much miles, or the miles, as the miles increases, how much the auto fare increases. Okay, so in this case, what kind of relationship exists between these two? These two are quantitative variable. Miles is a quantitative variable. Even this one is also a quantitative variable, numeric variable, right? So to find out the relationship between the two quantitative variable, right? So that is called your correlation. So we have something called scatter plot. It's kind of a scatter plot. And in the case of using scatter plot, we can find out, or we can plot the two quantitative variable. So by plotting the two quantitative variable, we can understand whether any correlation exists between these two numerical variable. As the miles increases, thus the auto fare also increases. Right? So if both of them are, increasing it, right, together. As the miles increases, the auto fare also increases. For other example, this is called your positive correlation. This is called your positive correlation. There exists a linear correlation. That means relationship. There exists a linear correlation exists between these two numeric variables. That is called, in this case, a positive relationship because the line goes upward. Okay. And the next example is here you want to predict the price. Sales. You want to predict the sales, and the y-axis and the x-axis you have the price. As the price increases, obviously the sales will increase or decrease. As the price increases, can the sales will increase or decrease? What happened? Fatima, she dropped, and okay. So I cannot monitor each and every people. Okay, here as the sales, as the price increases, what is going to happen here? Yes, you are correct. The sales will decline. Let's say you are selling a product at the cost of 10 rupees initially. We sell the product. Price is 10 and 20 and 30 and 40. So when the price is 10, obviously the sales is more, right? The sales is more. When you increase the price by 20, the sales will fall down and fall down, right? So in this case, also there exists a correlation, linear correlation exists between these two variables, sales and price. As the price increases, the sales is declining it. But in this case, it is called as a negative correlation. Sorry, guys. Once again, there is a net problem. Okay, so this is called your negative correlation. But still, there exists a relationship between these two variables. As the sales, as the price increases, the sales decreases in this case. Whereas in this case, as the miles increases, the fare is increasing it. Right. So both of them are, in this case, both of them are going the same direction. But whereas here, it is in the opposite direction. Right. So here in this case, what happens? This is called your negative correlation. Okay, negative correlation, positive correlation. And there are cases, no matter what advertisement I give. Somebody says, right, I spend spend on your advertisement and sales. Okay, and here no matter how much I spend, so $100, $200, $300, $400, no matter how much I spend, my sales remains as it is, only this much. My sales remains something like straight line. So how many have seen this one, the straight line? What does that straight line says in the ECG report? If you see the straight line, that means patient is no more. So here there is no relationship, correlation, or the relationship exists between these two numerical variables, which means even there is no point in spending money in advertisement. Okay, whether you spend money or not, the sales remains. As you increase the spend on advertisement, you don't see any increase in sales. It remains constant. Why should I? Since there is no relationship exists between these two, hence don't spend. And here the price increases, the sales is dropping. It is negative relation. Here there is zero correlation. This is called your zero correlation. The interview they'll ask you. These are the simple things. As part of screening, they'll ask you zero correlation. There exists zero correlation between these two variables, spend and sales. Sales and price, and sales and spend out of it. So now you understood with these three examples what is positive correlation, negative correlation, zero correlation. Can someone give me some example for positive correlation, negative correlation, some other example, including zero correlation? Give me some other example. Huh? Give me some example, not a problem. Make mistakes. First to open up, guys. If you are not open up, then they will think, you're you're not confident. This guy is not confident. He's not at all opening his mouth. Give me some example. Housing price, you can give, right? Housing price. Give me some. Type it in the chat window. Yes, Shri, you're correct. Shri and Sai Sudha, Soundarya, you three are correct. How about others? So even Shri, Sai Sudha, you are fresher, right? Yes. Soundarya has just 2 years experience. Please open up. What is, give me some other example, housing price. The y-axis, I wanted to predict the housing price. The x-axis, what can we use it in the case of housing price? Krishna, why don't you tell something? Krishna, Sarah, and Praveen. Praveen, you are correct. Yes. I think you are away from the system. Ashok, yes, you are correct. How about almost 50% of you have answered it correctly. So as the housing price, as the size of the house increases, the price will also increases, right? As your performance increases, your salary will increase. These are the example. Yeah. Your salary, how will your salary increase? Will they increase your salary blindly? No, right? Let's say you are owning a company. Can you give a salary hike to all the employees? No, right? Based on the the rating, right, or the performance, or the how much time they spent in office, right? Hours spent. The hours spent says obviously the productivity also more. Let's think that way, okay? They spend 8 hours, and some people they spend 10 hours, 12 hours, and 14 hours. The more the effort you spend, obviously they will see, okay, that is also one of the criteria. Okay, this guy deserves salary high. This guy is a dumb guy. He is not a high flyer. He just come for money and fun. That's all. So we don't need this kind of guy. They'll send out. Okay. And so this guy, yes. So as the salary increases, sorry, as the hours spent, the production, the manufacturing unit, the more the hours they spend, the production will be more, right? So let's say it's a TV manufacturing company. The employees are, the laborers are spending, or the employees are spending more time. Obviously, the number of productions, number of TV units production will be more. So these are the examples for the positive correlation, negative correlation, zero correlation also explained you. In the case of housing price, yes, as the price, housing price, this is your housing price, this is your square feet. As the square feet increases, the number of bedrooms, more the bedrooms, obviously the housing price will be more, right? If it's a double bedroom, it costs 1.3 crore. Okay. If it is a 3-bedroom house in a posh area, obviously it will be like 3.6 crore. So the third floor, my neighbor, he bought a house recently, 3.6 crore. As the square feet increases and the amenities increases, amenities also, gym is there, and a separate pool is there, swimming pool is there, all the amenities are there. Right? So more the amenities and more the square feet, the prices are high. The prices will go high. And even the as the housing, sorry, as the number of bedrooms increases, the housing price also increases. Okay, fine. So enough examples. Now you understood the positive relationship and negative relationship and zero correlation. Okay. Next thing is what you need to be aware. Now we understood what is Y is all about, what is the beta naught, beta 1 is all about, what is beta naught is all about. Okay. The next one is so now I'm going to plot the same thing, okay, in the x-axis and y-axis. let's this is your housing price. Your housing price, and this is what you want to, let's say in the x-axis you have the number of bedrooms. Double bedroom, the price will be here, and third 3-bedroom, the price will be somewhere here. If it is a 4-bedroom, the price will be more, right? So if it is a 6-bedroom, individual house, actress Kushbu, I saw her, bungalow here. Okay, it's a very big one. So as the number of bedrooms increases, the housing price also increases. Housing price is also increases. Okay, here, in this case, I have drawn a line here, right? The line. So this line touches all the data points, isn't it? So all the data points. This line is called your best fit line. This is also called as a y equal to your equation beta naught plus beta 1 x. This line, okay, if somebody says what is linear regression, modeling or fitting a straight line. Fitting a straight line in your model is called your best fit line or linear regression. Fitting a straight line. Fitting a straight line in your model is called your linear equation. Linear equation, straight line, linear line. You just think that a linear line. Linear is straight line. Your straight line, okay? So in this case, not necessarily it has to be, this way. It can be like in the opposite direction. But in this case, it is like this, okay? This is called your best fit line, which means this is the predicted, on top of this line only the predicted values will be there. So this best fit line, what exactly the best fit line? So all the predicted values lie on this one. For example, the housing price is actually here, okay? The housing price is somewhat here. We just think that, when you plot the data, right? So for the 2-bedroom house, what is the housing price? For example, 2-bedroom house, in the y-axis is, let's 1.2 crore, okay? And the 3-bedroom house, it is something like 1.6 crore. Sorry, not no, not on 3 point something, 3.6 crore. And so likewise, okay. So this is your x1, y1, x2, y2, something like that. So this is what we want to predict. The predicted values will be the housing. The predicted housing price will be lying on top of this best fit line. That is what called as a best fit line. The actual values are lying somewhere here, right? So somewhere the actual y value, the actual housing prices, something like forget about this one, right? So here the actual value is 1.2 crore, and this is 3.6 crore, and here you have something like let's 5.2 crore, and here you have something like 8 crore, 8C. So what is the predicted housing price? This is the actual value in the given data, whatever you have it, that when you plot it, it will be something like this, right? It will be something like, so this is, sorry, 1.2 crore, this is 3.6 crore, and this is 5.2 crore, and something like that. So 1.2, 3.6, 5.2, and 8. You just think that way. And here the estimated price is something like, 1. And for the 2-bedroom house, okay? The model, the machine learning model, when you remember auto fare, when you plug in the values, you get the estimated the auto fare, right? So that is what your estimated auto fare. That is what your estimated auto fare. What about the other one? This one, the second one is also estimated the housing price, right? For the 3-bedroom, what is it? So here 3.6 crore. Let's assume that my model predicted 3.2 crore, and here it predicted 4.8, something like that. Here 7.2 crore, okay, something like 7.2 crore, 4.8, 3.2, 1. So here the distance between the actual and this is called a predicted value. Predicted value. So these are all predicted value. Okay, P means predicted, and these are the actual values. Actual values, actual values, actual values, actual values. Okay. These are the actual values. These are the predicted values. So the distance between these two are called your error. So what is error? Error is equivalent to actual minus predicted. That is called your error. So your actual is 1.2 crore in this case. What is the predicted here? Guys, can you all please make it, so I could see still people are lacking interest here. I don't know how much I can motivate. Okay, now you tell me, all of you, what is the predicted value here? So this is the actual endpoint, right? What is the predicted value here? Yes, Sri, you are correct. Except Sri and Sai Sudha, Praveen, and Soundarya is not there. Okay. So Ashok, you are correct. And how about others? What is this value predicted? Predicted is 1, right? As per this, the predicted values are lying on top of this line. This is the predicted value, right? So the 1. So 1.2 minus 1 is how much? 0.2. The error is 0.2, 0.2. And similarly, what is the estimated housing price? 3.2. What is the actual? 3.6 here. Actual is 3.6 crore. The estimated is 3.2 crore. So the difference is 0.4, right? 0.4. This is an error, right? So this one, the actual and predicted. The error is error 1 and error 2. And this is for the second value, right? For each and every y value, we need to find out the error. So y minus y hat. We can also say the actual is y, the predicted is y hat. Y hat is your predicted value. Predicted values are lying on top of this line. Okay, so the error 2. And what is the error 3? What is the error 3? All of you please type it in the chat window. Sriram is missing. And how about Danraj? Danraj is missing. Jay Prashant, Jay Shri, can you tell me what is the E3 here? What is the E3 here? Yes, you are correct, right? Sri Krishna, you are correct. All the others are correct. How about Jay Shri and Jay Prashant? Are you there in the call? Jivanandam. What is the actual and predicted here, yaar? See here, predicted is 1 I put. 3 P, all the P's are predicted. The above actual, everything circled on top, right? That is your actual value. Actual minus predicted, that is what your error. It's something like, somebody visited your house and they give the estimation. Before starting the painting, they give the estimation, sir, it comes around 7 lakhs. Estimated cost is 7 lakhs. Okay, 7 lakhs. But what is the actual? This one, before you started the painting work, you gave the quote, 7 lakhs. What is the actual? The estimated and actual will not be same all the time, right? But when they started painting it, they realized, sir, it requires additional liters of petrol because the walls were damaged very badly in the south and west facing, the third floor houses. Hence, it requires additional. So let's the actual is 7.8 lakhs. So the what is the difference between the actual and predicted? The estimated is 7, right? 7.8 minus 7, that is your 0.8. That is your error. That means they did not, the more the error will be there. Let's say instead of, let's say the guy says before painting it, it is 7 lakhs, sir. After started painting, right, within 15 days, he comes back to you, sir, it will cost you 15 lakhs. What will happen? What will happen? என்ன ஆகும் 7 லட்ச ரூபாய் சொன்னான் அப்புறமா திடீர்னு சரி பெயிண்டிங் முடிக்க 30 நாள் ஆகுங்கிறோம் ஆனா 15 நாள்ல வந்துட்டு 15வது நாளே வந்து சார் இது வந்து 15 லட்சம் ஆகும் என்ன பண்ணுவீங்க again you need to call all the members in apartment you conduct a meeting and then tell them so everyone will say sorry we have to stop the painting எங்கிட்ட பணம் இல்லப்பா நீ எடுத்த உடனே எல்லாம் எங்ககிட்ட ஒரு வீட்லயும் 1 லட்சம் மறுபடியும் கேட்குற இல்லையா so more the variation the actual and estimated, the difference is more. அவன் சொன்னதுக்கு மேல நிறைய ஆயிடுச்சு, அப்போ டிஃபரன்ஸ் நிறைய இருக்கு அப்படின்னா எரர் நிறைய இருக்கு. எரர் நிறைய இருந்தா அது இம்பாக்ட் நிறைய இருக்கும் இல்லையா? The work will not proceeded, right? So if it is a minor variation, so lesser the error, better the prediction. இப்போ வந்து ஆக்சுவலுக்கும் ஆக்சுவல் அவன் வந்து கொடுத்த எஸ்டிமேட்டட் காஸ்ட்டுக்கும் 7 லட்சத்துக்கும் நம்ம பெயிண்ட் அடிச்சதுக்கு அப்புறமா அவன் அடிச்சவன் டிஃபரன்ஸ் பார்த்தா ஒண்ணுமே இல்லை. 7 லட்சம் ரூபாய் சொன்னா 7,10,000 ரூபாய் இருக்கு, அவ்வளவுதான். பெருசா ஒன்றும் ஆகல. 10,000 ரூபாய் தான் மிச்சமா இருக்கு. 7 லட்சம் சொன்னா 7 லட்சத்துல முடிச்சிட்டான்ப்பா. பெஸ்ட் அக்யூரசி இஸ் பெஸ்ட். The difference between actual and estimated is 0, means the prediction accuracy is very good, but in real life la andha mari varadu. The predicted value and actual will be, there will be some kind of variation. That variation is very less, then it is good. If it is too high, that means the prediction error, right? So there is an error in the prediction. It is not affordable. The error in the prediction is very high. Hence the model did not do the good job. We built the model, we trained the model, linear regression, but it is not predicting well. So it requires some kind of fine tuning. Okay, so what we will do is we will find out, are there any other additional independent variables we can include in our model? So number of bedroom and square feet and car park, other amenities and locality. Idella add panni paataka. So okay, so after including the additional independent variable which are significant, the model can now predict with better accuracy. Accuracy, you understood, right? What is accuracy? The difference between actual and estimated should be very less. Very, very less. If it is too high, right, it is not accurate. It is something wrong with your model. So here, what I'm trying to say is the best fit line. Again, I'm going to draw the line here. For example, this is your best fit line. Your model detected the best fit line. Okay, let's say your actual values are here. So your actual housing price is something like 1 crore and 1C, and other one is something like other houses, right? Other houses 1 crore, another house is 0.8 crore. Okay, and there are some houses, not this one. Okay, other house, there are some houses it costs 2 crore. There are some other houses it costs 3 crore, right? There are some other houses it costs 2.8 because of the area, another thing, 2.8 crore. So you plotted the value given by your manager. For example, this is the data set. Okay, for example, so in this case, the bedroom, right? Number of bedroom. I'll just put it on a table here. So number of bedrooms and the price, they've given you this one. And here the 2 bedroom, 3 bedroom, 4 bedroom, and 5 bedroom and 6 bedroom. Here, if you see here, the price, right? Forget about this one. The price is two bedroom houses 1 crore, and 3. Let's this is 3 crore and 4.5. Idhula vechikkalama. Okay, so 1C, and this is 3 bedroom is 2 crore, and 4 bedroom is 3 crore. Okay, and 5 bedroom is, in this case, it comes around another 5 bedroom is 2.8 crore. Okay, this is 3 crore, something like 1, 2, 3. This one. So 1, 2, 3, and 2.8 crore. And we have another house, right? 2 bedroom house that costs around 0.8 crore. Apna 80 lakhs. So when you plotted this value, Sorry, you're not audible, sir. Okay. So these are all the prices. This is your 1 crore. This is your 0.86 lakhs, which means less than, sorry, 86 lakhs or zero point 0.8 crore, right? 0.86 crore. And this one is your 2 crore. And here it comes around close to, let's say, 1.98 lakhs. And here you get something like, or here, what are the 4 bedroom, right? Sorry, this is your 3 bedroom, 4 bedroom, 5 bedroom. Okay, 2, 3, 4, 5. So 2 crore. And for the same, this one maybe, because of the square feet, right? This one, or let's say, the 3 bedroom house costs somewhere 86 lakhs and it is 2 crore. Okay, depends on the location. You just think that way. And here, 4 bedroom cost is in one case it comes around 3 crore, and some cases it comes around 2.5 crore. Okay, and five, this one is here. Obviously, you will get for 6 crore, something like that. Okay, so here we have the data points. The actual values are here, here, and here. If I ask you to draw a best fit line, forget about this one, okay? Where will you draw? That, I cannot draw a line on top of this one because we have some other values are there here. Are you able to understand? I cannot draw a line on top of these dots because I have other values are there here. So, இது ரெண்டுத்துக்கும் பொதுவா மத்தியஸ்தம் சொல்றான் இல்லையா, பொதுவா வந்து இங்க ஒரு லைன் போடுறோம். இந்த லைன் வந்து பாத்தீங்கன்னா இதுல ப்ரெடிக்டட் வேல்யூ இங்க இருக்கும், இதுக்கு 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 ப்ரெடிக்டட் வேல்யூ இங்க இருக்கும். புரிஞ்சுதா? ஸோ திஸ் இஸ் யுவர் ஆக்சுவல். தி 1 crore தான் ஆக்சுவல் பிரைஸ். என் மாடல் எவ்வளவு ப்ரெடிக்ட் பண்ணியிருக்கு? என் மாடல் வந்து ப்ரெடிக்ட் பண்ணது பாத்தீங்கன்னா இங்க வந்து பாயிண்ட் இங்க வந்து பாயிண்ட் ஓகே 0.86 0.89 பண்ணியிருக்குன்னு வச்சுக்கோங்க. ஸோ திஸ் இஸ் வாட் யுவர் ப்ரெடிக்டட் வேல்யூஸ். இந்த மேல இந்த லைன்ல திஸ் இஸ் கால்ட் யுவர் ப்ரெடிக்டட் லைன். யார் predicted values, prediction line, okay, or a prediction line. So because all the predicted values are there here. This is the actual value. For the same bedroom, when I asked my linear regression model to make a prediction or the estimated housing price, it gave me something like 0.89 and 0.86 crore, something like that. So in this case, you tell me what is the, so the difference between these two are what, right? But instead of drawing a line here, if I draw a line somewhat closer to this, what will happen? This is fine, the distance will be less. This is your actual and your predicted values here. The distance is very less here. This is called your error one, right? But this is for your line B. This is what your line A. If the distance between this value and this predicted value is very less here, right? But if you find out the distance between this value and this value, sorry, point, yeah, if you find out the distance between this one and the predicted value, so since this line is too far from this, see this value is here, right? This data point is here. The distance between this one and this is too far because your predicted value is here. This is your actual value. The distance between this, I'll just maximize this one. See, something like, you just, let's go work on this 2 bedroom. The one house costs 1 crore. Sorry, let's 1 crore, but my model predicted, the predicted value is 0.86 or 0.96 irukku. If I draw a line here, if I draw an அதே 2 bedroom house இன்னொரு இடத்துல என்ன இருக்குன்னா, the actual value வந்து 1C, இன்னொன்று வந்து பாத்தீங்கன்னா அது வந்து 0.82 lakhs, 0.82 lakhs. This is another house. Okay, this is 2-bedroom house. ஒரு வீடு பார்த்தீங்கன்னா 0.82ல இருக்கு, இன்னொரு வீடு பார்த்தா 1 crore இருக்கு. பட் மாடல் எவ்வளவு ப்ரிடிக்ட் பண்ணிருக்கு? இந்த 1 crore 0.86 பண்ணிருக்கு. 0.82க்கு இந்த மாடல் வந்து ப்ரிடிக்டட் சம் அதர் வேல்யூ. ஓகே, இப்போ இஃப் ஐ ட்ரா, இப்போ வந்து I need to find out the difference between actual and predicted. What is the actual? This is the actual, right? This is your actual. The predicted value is 0.86 predicted. How do you find out the difference between these two? The distance between these two. This is your original value. This is your predicted value. The cross mark. So 0.96 was the predicted one. The actual minus predicted. What is that? That is called your error. Actual is what? 1 crore, right? My predicted is 0.86. Got it? So your actual is here, your predicted is here. In this case, if you draw a line here, okay, the distance between actual and predicted, that is what I have written it as a equation here. Actual minus predicted. So the actual is 1 crore and the predicted is 0.86. The difference between these two are 0.14. The distance is 0.14. I'll just write it here also. 0.14. The difference is 0.14, right? These were actual and these were predicted. The difference is 0.14. Right. So next one is, okay, the same 2-bedroom house in other location is 0.82 lakhs. And that data point, since this value is lesser than 1 crore, obviously somewhere it will appear here, right? ஒரு x-axis y-axis plot பண்ணும்போது higher the value மேல போகும், கம்மியா இருக்க value கீழே தானே வரும் இல்லையா? So in this case, this one, for this house, the actual value is 0.82. பட் ப்ரிடிக்டட் வேல்யூ வந்து இதுக்கு வந்து பார்த்தீங்கன்னா 0.81 இருக்கு, சரியா? ப்ரிடிக்டட் வேல்யூ. இதுக்கு ப்ரிடிக்டட் வேல்யூ வந்து இங்க இருக்கு 0.81. பட் இதுவே வந்து நம்ம ஃபார் எக்ஸாம்பிள், இஃப் யூ ட்ரா அ லைன் somewhat closer to this one, what will happen? The predicted value appear here. The distance between these two are less, right? The distance between these two are less. Hence the error is less good. But this line is too far from this value, right? Hence the actual and predicted value, the difference between actual and predicted value, inga vandu enna the actual and predicted? Actual is 0.82, but my predicted is something like 0.81 vechko. So inga vandu enna agum ungalku subtract panningna 0.1, right? This is error. Fine. But in this case, since this line is too far from this value, the distance will be more. The error will be more. Okay. Hence, we cannot draw, right? You need to make sure that the line should drawn in such a way it is close to as many data points as possible. That is, so in this case, I can also draw a line here, right? Yes, you are correct, Shri. So this is where best fit line. இப்போ இவருக்கு உங்களுக்கு மட்டும் சாதகமா, ஒரு ஆளுக்கு மட்டும் சாதகமா பேசினா மற்ற ஆளுக்கு அது பாதகம் ஆகும் இல்லையா? 2 பேருக்கும் எந்தவித பாதகமும் இல்லாம நடுநிலைமையில பேசுறோம்ல, அதான் பெஸ்ட் ஃபிட் லைன். புரிஞ்சுக்கோங்க. ஸோ இங்கிலீஷ்ல சொன்னா என்ன பண்றோம்? The best fit line is nothing but which covers as many data points as close to the data points which covers as many data points as possible, right? Or the line which covers as many data points as possible. That is what is called your best fit line. முடிஞ்சு போச்சு. You cannot draw a line here. You can draw n number of line, but the line which reduces the error is called your best fit line. But if you use the line A, you think, for this actual value it reduces the error, but for this actual value, since the distance is too far, the error is more. But instead of drawing, instead of using the A, if I use B is optimal, right? The distance between, this value and this value are almost similar. Hence, this is called hence it can minimize the error. The best fit line is nothing but the least square. It is also called the least squared error. Least square error. Okay, this is also called the least square error. Okay. Got it? So now we understood what is error. Error is nothing but, I gave you the example, painting example. Okay. So if some, the predicted is something like estimated value. Actual, after once they started doing the painting, how much we are incurring actually, right? That is what your actual. Difference between actual and predicted is called your error. So this is for one data point. For likewise, for each and every data point, the error is computed. Okay, the error is computed, and we, each and every error we square it. Okay, we square it. That is called your sum of squared error. Okay, sum of squared error. All right. See, there is some problem with my net connection. Every now and then, now I just connected with my hotspot. Anytime it may go down. So what I will do is, right, we will continue tomorrow. I will make sure that I will call these guys and blast them and get the work